+2 non-medical, and the topic of my presentation today is chemical kinetics. Chemical kinetics is the branch of chemistry which deals with the study of reaction rates and their mechanisms. Thermodynamics tells us only about the feasibility of a reaction, whereas chemical kinetics tells us about the rate of a reaction. For example, thermodynamic data indicate that diamond shall convert to graphite, but in reality, the conversion rate is so slow that the change is not perceptible at all. Kinetic studies not only help us determine the speed of rate of a chemical reaction, but also describe the conditions by which the reaction rates can be altered. The factors such as concentration, temperature, pressure, and catalyst affect the rate of reaction. Rate of a chemical reaction. The speed of a reaction or the rate of a reaction can be defined as a change in concentration of a reactant or product in unit time. It can express in the terms of the rate of decrease in concentration in any of the reactants or the rate of increase in concentration in any of the products. The rate of a chemical reaction. Consider a hypothetical reaction assuming that the volume of the system remains constant, as given below. 1 mole of reactant R produces 1 mole of product P. If R1 and P1 are the concentrations of R respectively, and that the time T land R2 and P2 are the concentrations at time T2, then as given below is the reaction. The square brackets in the above expressions are used to express molar concentration. The rate of a chemical reaction. Rate of disappearance of R is equals to decrease in concentration of R divided by time taken. Rate of appearance of P is increase in concentration of P divided by the time taken. Since delta R is a negative quantity, it is multiplied with -1 to make the rate of the reaction a positive quantity. Consider the following chemical reaction as given below. General rate of reaction is also given below. Rate of reaction is equals to rate of disappearance of reactants is also given below. Average rate and instantaneous rate. Average rate depends upon the change in concentration of reactants or products and the time taken for that change to occur. Equations 1 to 3 represent the average rate of a reaction. The rate of reaction at a particular moment of time is known as the instantaneous rate. It is obtained when we consider the average rate at the smallest time interval, say dt. Mathematically, for an instantaneous similarly small time interval, dt instantaneous rate is given by the units of rate reaction are mole, liter inverse, second inverse. The given graph below shows it. Initial rate, average rate over a time period, instantaneous rate, slope of tangent. Factors affecting the rate of a chemical reaction. Number 1, nature of reactant. Ionic substance react much faster than covalent substances. Concentration of reactants. Rate of reaction is directly proportional to the concentration of reactants. Temperature. Increase of reaction increases with increase in temperature. Presence of catalyst. A catalyst alters the rate of a reaction. Surface area of reactants. Rate of reactants is directly proportional to the surface area. Collision theory. Reaction occurs when the reacting species have sufficient energy to collide in proper orientation in space. Energy barrier. The minimum energy in which the colliding particles possess in order to bring out the chemical reaction is called threshold energy. The energy difference between threshold energy and average energy of reacting molecules is called activation energy. Orientation barrier. Colliding molecules should be in the proper orientation at the time of the collision. Transition state theory. In the activity complex theory, we consider two reactants approaching and the potential energy rising and reaching a maximum. as given in the graph below. Activation energy. The energy needed to form activated complex is called energy of activation. It is very low for some reactions and very high for others. Thank you very much.